This is the brief on the physics and mathematical formulation of centrifugal force. We're going to cut through the usual textbook complexity here. We're really just going to zero in on two core aspects of centrifugal force. Its very specific spatial rules and the, well, elegant way advanced math describes it. So first up, centrifugal force has this remarkably strict rule about space. Its strength is determined only by the particle's radial distance from the axis of rotation. So what does that mean? Well, it means the particle's height, its vertical position. It doesn't matter at all. As long as its outward distance is fixed, the force is constant. The only way for that force to completely vanish is if you pull the particle right onto the axis, making the radial distance zero. Second, and this is where it gets really cool, is how this is all described with math. You can boil the whole thing down using something called a tensor. Now, you might see the vector equation with all the cross products, which looks pretty complex, but the tensor form is just incredibly concise. It shows that the force is structurally linked to this tensor, which itself is built from the mass and angular velocity. It just strips away all the complexity. Centrifugal force is a purely radial phenomenon that finds its most precise definition in the language of tensors.